Draft physics video. Oh, what was that? Microphone wire. Sorry. Technical difficulty of some kind. Anyway, yeah, I thought this would be maybe just a kind of an overview video. But I have the overview stuff on the wrong computer. Anyway, I figured I'd read a comment first and then I'll switch. If that, if what, okay, it says yet. Anyway, you're saying is true, how come we observe double sun solar systems? I don't know how many of them we observe, but anyway, if gravity is a conservative force, retard. Obviously, they're the same reason why Jupiter and Saturn and all the big gas balls are out there. They had to be formed in their location. They didn't come from the outside and find the orbit. They were created in the spot they exist. So if there's a double sun solar system, you can probably bet good money that it wasn't created by two suns colliding with each other or interacting with each other. That it was created by two big objects in the very early creation of the solar system being capable of catching fire. When they crash into each other without getting into a spiral first. Yes, that's how all the planets were created. It's a bunch of stuff hit them. They crashed into a lot of stuff to be in the orbits they're in. So it sounds like you're talking absolute shit to me. So that's okay. So if the actual Einsteinian and Newtonian laws of gravity are absolute shit to you, fine. It's okay. I mean, I can't do anything for you then. But that's how gravity works. It's the force. That's how, that's how they landed on the moon. Because they didn't have enough fuel to get back. So they landed on the moon by shooting themselves into an orbit at the right speed around the moon. They could control their speed, you see, so they could get in an orbit and slingshot. But I mean, those are the rules of gravity. And I'm sorry you don't like them, but planets don't have guidance systems and can't adjust their velocity. And the implications of the inverse square law and the implications of the conservative force, meaning it's just as much energy to get out as it takes to get pushed in. So as much as you think of this bent space model, it's not really true. It's an energy equation. It took energy to move faster, and you have that energy when you get to the sun, so to speak, or near it. And if you pass the sun, you have the energy to escape. It's just the way it is. You don't like it. I'm talking absolute shit by pointing out how it is. Okay. Got it. So anyway, I guess I'll make one correction on the Lygos thing. I'm just going based on my recollections. As I recall the way they described it at the press conference, they were talking about two black holes got into this incredible, dance of death or whatever they called it. And, they really didn't say it was two black holes in a binary system. They didn't say that. Maybe they just didn't feel like adding that complication or something. But anyway, okay. So I don't get to critique how the two black holes became a binary system. I mean, we don't even know how one black hole exactly gets created. Two of them, they're right next to each other. Well, anyway. But whether they could get up to the speed of half the speed of light and all that crap, I'm no comment on that either. But clearly, the biggest point I have is the signal that is the first half of the signal. It's not supposed to be leaking solar masses then. It's just supposed to be leaking a little bit of radiation. I mean, the whole reason why the two black holes collide is apparently because the black holes lose energy somewhere that somehow we can't detect. some kind of special energy. Most things caught up in systems like that would be what's called an X-ray source. Most binary, most heavy things in two big things in an orbit, they end up shearing, and a lot of X-rays are produced because a lot of the crap from one of them ends up getting fried by the other one. But anyway, they end up being X-ray sources, and no word of any X-ray sources that did anything spectacular at the same time. But anyway, whatever. Alright, so an overview. Alright, current physics has these arguments about what the structure is. So you have the Einstein stuff. See, Einstein is kind of a mixed bag, because you have the Einstein stuff that is very particle on the quantum side, the small side, and then in the big universe he uses this bent space idea and this idea of bent space-time as the mechanism that causes the attraction between celestial bodies. So it's clearly a kind of a medium. It probably never should have been called space, because space sort of implies empty space, not something space. So that's sort of bogus. And as the Ken Wheeler guy sort of illustrates, it is kind of silly to be talking about your wave theories when you're not talking about the medium that's causing them, that's waving, quote unquote. And the idea of bent space is just kind of saying there's some sort of superstructure that detects the mass of objects and recognizes their mass, let's say, their atomic weight. Because if I spread it out, it doesn't sink as deep somehow as if I condense it into a ball. So if I have it flat, it doesn't bend the fabric as much as that if I condense it into a ball, then it bends the fabric more. These kind of rules. So this substance, this infrastructure, somehow detects mass and appropriately, depending on the configuration of the mass, creates attraction, quote unquote. Then on the quantum side, so that's the big universe with the big balls of stuff moving around that are clearly particles. I mean, it's clearly a particle universe, and you're just saying that there's something non-particle, non-material, that's creating the movement. That movement isn't something caused by a physical mechanism. It's physical in the sense of anything we can detect with any instrument, beyond dropping something. You know, hey, I detected gravity. No machinery, no mechanism we know of that made the pen go down. Space itself somehow did it. But we know that space itself is nothing, so the medium, the ether, did it. So it's essentially an ether theory for the big universe. And for the small universe, we have this obsession with waves and probability and words like uncertainty. And like these are things built into the structure. So their theory of how it works is to basically say it has built into it probability calculus, and the mechanism isn't being caused, say, by some physical cause, like, you know, there could be, this could be a triangle, and you could calculate what percentage of the triangle is the point. And you could say, if you were to randomly drop something, what's the odds of hitting the point? So they're not saying the probability is that kind of probability, like there's a physical structure that imposes the probability. More like the thing is not in any place, and it, by statistical analysis, by statistical something, somehow it knows how to make it all turn out right in the end. So there's a random engine that's a perfect random engine in a sense, and it randomizes the where you're going. So you have, again, non-real things telling the what you think to be real things, photon, electron, proton, neutron, what to do. But it's in this quantized way where everything has a discrete, a confined energy potential, you could say. How else to say that? So it ends up being wave-particle duality, in the sense that they have to accept the quantized part is the idea of the particle, the wave part is the we're going to give the waves the capacity to transmit the force through some kind of field. Some sort of field is waving or moving, and but they still have to account for what causes that, and that's why I'd say they still fail, because you still need energy to cause the transmission of something through the medium. And I would argue that in both these cases, in the quantum level and at the big universe level, they're not accounting for the energy that's causing the effect. So Einstein's bent space essentially is an unaccountable source of energy. Nobody has to explain where it came from. The Earth doesn't burn any fuel to go faster if it's heading for the sun. Nothing has to use any energy, because you have this idea that somehow it's given back when it leaves, quote unquote. And so therefore you don't have to account for its creation and consumption. But the better illustration for that is probably magnetism, because clearly the magnet, especially an electromagnet, is clearly in states that are on and off, and the regular magnet is probably the better example, and that something has to be creating what is the field that is energized when the magnet. So if I put a magnet in this space, the field around it is a different field. So something's changing the field, and there's no accounting for the energy required to change that field. And in big space, nothing's accounting for all this movement, the source of the energy. All right. So I'm arguing that these are incompatible theories, first off. They're small quantized theory of waves and uncertainty principles and entanglement and whatever isn't going to fit with this space being bent, and time also, so we have to include that one also. Time isn't just a function of movement, a consequence of it. It's some other thing, another field, another place that can be warped or bent or twisted and somehow shorten distances or lengthen distances. Okay, so I'm saying that stuff isn't, it's too, the big universe theory is too different from the small universe theory. There's too little tying the two together. We can argue that the space between two atoms, the empty space, and the empty space in between two galaxies, it's the same empty space. So the little universe is functioning in the same universe the big stuff is functioning in, and that those rules have to be the same for the entire universe. It's one universe. And the rules should be consistent because the little bits are essentially creating the big bits. What you see in the big universe is a reflection of what the functions of the little stuff. Not that they have to look alike, but just that they have to have, there has to be a connection. If bent space is moving atomic particles through a process of gravity, then bent space has to be accounted for in the quantum mechanics of how things function. And it really can't, because everything on that level is magnetism and electricity, which are basically the same thing. So anyway, so what I'm arguing is that you can simplify the whole thing by just following the energy, just thinking in terms of quantum theory, in terms of what's the smallest bit of something in the universe, what's the smallest impact you can have on something, and that would be like a photon. And all the other forces, magnetism and gravity, I'm saying light's a force, they all move the same speed, and they all have this very small, they're very granular, very tiny bits of energy can be transferred through these mechanisms. And so I'm arguing that it's all the same thing. You don't need an ether field. You just have to think in terms of a field of bits that are moving. All right. And it'll all add up, okay, because you can think that everything that does hit something has a certain amount of those little bits. The amount of energy that goes into something is in it until something else, the energy is transferred to something else, because energy is just movement in a direction. And so you just follow the movement. It has to leave somewhere. If the thing's going to stop moving, the movement has to go into something else. All right. Yeah. So I guess I'll get to my point. So if we simplify the universe as simple as you could think of simplifying it, like let's just say a bit, a tiny little bit, and it moves the speed of light. And then if you filled the universe full of those little bits moving the speed of light, and let's say they could hit each other, you could sort of understand that a bit would end up constantly getting hit. So if he was going this way, he'd end up hitting somebody going exactly the opposite way, and he'd go, let's say he reflected, then he would be going this way, and then he'd end up hitting somebody going this way, and so he'd end up going back this way again. And if you could understand that there was a sort of equal amount of this happening, he wouldn't get very far. He could just spend 1 billion years just going back and forth, back and forth, back and forth. And that's all he'd ever do. Nothing interesting would ever happen, because nothing beyond these reflections could happen. So all he could do is get reflected in a direction. So even if something hit him this way, something else is going to hit him back this way. So he could never really get anywhere, because there would have to be a complete lack of stuff coming from one direction for him ever to get pushed any number of ways this way, because just the law of averages, heads versus tails, will just end up keep moving him back to where he started, and he'll never get anywhere. He'll just move around, but always end up stuck in a little circle of possibilities, of random, oh, I got 3 in a row this way, so he actually goes somewhere, but he won't go for very long, but sooner or later he's going to get 5 in a row the opposite way. Anyway, it'll all end up back in the same place is the point. You can just think over time there's just going to be this simple thing where it's going to be just one or two directions, and that's it. You can never be off very far. It can't be too far from the home. Alright, so we know the universe doesn't work that way. Okay, because that doesn't do anything. Nothing changes. So you start to add something else that makes that possible, something new. And it's hard for me, I can't add it in some incremental way, like just go from, okay, let's take that and let's add something to it, but I'll attempt to do something similar. So because we know polarization exists for magnets and other things, the next change would be not intuitive or not something you would say, oh yeah, the way I'll make something happen is I'll make two colors. There's little bits that are red and little bits that are, let's see, red pen, and little bits that are black. And the red bits are on lines and the black bits are on lines, so to speak, on tracks, let's say, or possible paths of movement. And the two can't intersect. So the black bits are all on the odd number rails and the red bits move on the even number rails, however you want to think about it, but their geometry is such that they never intersect. And that doesn't help you much, right? Because the reds will just keep the reds in the same position and the blacks will keep the blacks in the same position. Like I said, this doesn't help any, but it helps later. So there's nothing I can do about that in terms of doing the explaining. Because the having the two bits is what gives you the power to turn the force on and off, so to speak, and that's what makes the universe change. Alright, so then you say, okay, so you have those bits, and so they don't go very far. The little black bit will move around here, the little red bit will move around here, and that's it. Not much happening. So you need something else to make it possible for something interesting to happen. So what I would argue is the matter bit shows up. And the matter bits will be made out of either red or black. And the matter bits have a special property in the sense that they might be just made out of these little bits compressed together. But what they really are allowing to have happen is they're allowing the connection between the red and the black. They're now able to intersect in a way that they weren't before. Could be anyway. This is probably I'm probably getting more technical than is useful, but regardless. So let's just say the matter bits are sensitive to, there's matter bits made of the colors, okay, and those would be your electron and your proton, essentially. Alright, your positive and negative charged particle. And that, in my opinion, see, regular physics has a whole bunch of different things, quarks and all kinds of half charge and this charge and that charge, and all that's kind of unnecessary to understand any of this, but none of that stuff really exists doing anything in the universe we know of. You don't detect any of those things in common experiments. You only detect those things when you smash things and explode them, then those bits show up. So they might be real, but they don't have anything to do with the real function of the universe, in the sense that the normal function doesn't include them as active players. But anyway, they might have something to do with the structure that is these bits, though, the electron and the proton. Alright, so anyway, so if you throw these things into the mix, and then you just make a couple of rules about how they behave, you can see pretty quickly how the problem of these little bits not going anywhere is resolved. So if you say the black bit, when a black thing hits it, okay, it can do two things. There's two, we have a couple of choices, let's just say, kinetically. It can hit it and move it forward and cause a reflection backward. So this will go one little step forward, and the thing that hit it is going to leave continuing to go. Now whether this has captured the momentum and keeps moving is a more complex question. But anyway, the plus arrow ends up being part of this matter, and so the matter moves this way, and the reflection goes back, and so that's pretty standard. And, you know, and in a sense it doesn't add up to anything, because you could understand that if a bit comes, this bit caused this thing to move this way, well, you can understand there's going to be a bit coming from this direction, and it'll just end up making it go back the other way. So the matter has the same problem, where it's just going back and forth. And if I put another piece of matter here, you can understand that this will just do the same thing. If this one ends up having a velocity towards this one, and they're reflecting, it just means these reflections will happen more often. And so you'll end up with more pressure here, and that'll make it go back away. And so that's the repulsive force, you know, the basic force of repulsion between electrons. And protons on protons would be the same way. So if I drew this in red, it would be the same rule, basically. That if red force collects between here, then the closer you bring these objects together, the more times you get a reflection. So now you have a system where things can move, but they can't move terribly erratically. And like I said, I can go into the you know, well, I don't want to go into, yeah, I won't bother with the more complex explanation, but that's the simple. So I would argue that this is your photon, and this is also the forces you store in a battery, are the potential you possess when you're shot out of a gun. Anything that gives you force, this is where you're storing it. And when you release it, it'll be released as things at a frequency, and that's a photon. But anyway, the trickier part is, I won't even say, it's not released this way, so anyway, I won't get into that. Alright, so the other trick is, so this universe would get you something, but it's still not going to get you much complexity. And so where it gets interesting is, if a red thing hits the black thing, so I'll redraw it, instead of the reflection being just plain back, if a red hits a black, or a black hits a red, what happens is the reflection that you would expect back instead goes out perpendicularly. And so what happened, basically, the argument being made is that there was a black going this way, and the red hits the black perpendicularly, takes the identity and switches identity. So the black ends up going this way, so the black turns this way, and the red turns this way. Now, with this arrangement, you can sort of see that if a red and a black thing were next to each other, I'm going to draw it red. So you have a proton and an electron. You can sort of understand that no force could get trapped between them, because the red ones will all go out perpendicularly, so they can't keep going back and forth. There's no reflection back at the object. And likewise for blacks going out of this thing to this, they would end up leaking out perpendicularly out of the proton. So there can't be anything trapped in here. So if there is any external force still active, there's no internal, so that there's no pressure here from reflections, so the two objects will get pushed into each other. Because anything red or black, if a black hits this way, it will reflect and cause movement this way. But if a red hits this way, it'll go out perpendicularly, and so it won't hit the red, which is the purest of the reflections. Alright. Anyway, so that's a basic diagram of what the implications of polarization would be, of having two kinds of matter. And so for magnetism, you know, this is just a general argument explaining what attraction and repulsion are. Repulsion is trapping force between two electrons, for example, or between two protons, and that's repulsion. And attraction is when their force is set free. There's an escape valve, and so the pressure escapes, and so there's no pressure, and therefore the two things are pushed into each other. So there aren't any pull forces in real physics. It's all an absence of the push. So if you have push from both sides, something doesn't move. But if you only have push on one side, it moves. And we see that as something we call attraction when there happens to be something over here. But it's really not attraction. It's clearly a push. Alright, and for magnetism, the idea would be is the magnetic material is just polarized, which means that anything that goes through it comes out the color of the size, the side. So anything red coming in here comes out black. So if something red comes in this way, it comes out this end black. And if it's black, it comes out black, of course. And the same is happening at the bottom, so everything gets changed to red coming out this end, and everything goes black at the other end. And clearly the blackest will be these two end pieces. The force coming out of them will be a solid black and solid red. It'll be the purest, because there's no way for anything to, there's no angle you could go through where you can't miss this black line, so to speak. You can't get out anywhere here by going halfway through or something. There's no path where here, let's say if you're in this location, there's plenty of reds that'll end up going this way. So there's always going to be a mixture of red and black coming up the sides. So there's more of a mix here. In the middle of the magnet is the most mix of black and red, because the blacks can get this way and the reds can get that way. But the purest will be at the two ends, and that's where the strongest polarization is, which ends up being the strongest force in terms of magnetism. So a magnet's just taking the field energy we started with, the little bits moving randomly, and it's just saying we're going to segregate them. The red ones will be coming out one end, the black ones will come out the other end. And then they'll be able to push things like electrons and protons individually, separately, and create the same force as an electron. The magnet will behave, this end will behave like an electron, and it will repel electrons. This end will behave like a proton, and it will attract electrons, and it will repel protons. And therefore, when you move that magnet near a conductor, you're going to be moving the protons and the electrons towards the magnetic field proportional to that attraction. And that movement is going to be called electricity. Is going to make something called electricity. But the real point is what it is the compressions between the electrons is really what's going to get changed. And so as you move the magnet, you're pushing electrons in one direction, because the attractive end of the magnet is pulling electrons, the other end is pushing them forward, so both effects are in one direction, and that ends up compressing all the electrons which means all the black arrows between them start bouncing a lot more often, which creates a lot more pressure, and that ends up being your voltage. Yeah, so it's reasonably stated, I think. Alright, so the most complex part of it is, well, it's not the most complex. When you it's really easy if you just think of it mechanically. You're saying, again, it's just these little bits, so you just add up how many little bits went somewhere, and you know how fast something's going. So if I want to give the pen velocity by imposing force into it, pushing it with force, the force goes inside of it. The little bits go inside of it, and it holds them. And unless something takes them away, which is in this circumstance, gravity is coming in and essentially undoing that velocity and converting it to a new velocity going down. But you can sort of follow the bits. I mean, you just follow the pressure, and everything's just going wherever the pressure forces it to go. Nothing goes anywhere because it wants to go there or any of that kind of stuff. It goes where the pressure pushes it, where the pressure exists. And it exists in lots of weird circumstances because of you can sort of understand that if this is a proton and a black bit comes in, it's a red thing, my fist, and a black thing comes in, it's going to leave perpendicular. You can understand if there's another proton here that it could go in and leave perpendicularly, and you can end up with a circle. So you can end up trapping energy, force, bits, in arrangements and consolidations. And that's sort of the idea of anything that stores energy, is that's essentially what it's doing. It's finding a way to create a path for the quanta that it's collecting. And it's just creating places, little ways to force the energy just to go around in circles. So it doesn't go anywhere, do anything, until you release it, and then it is a real force again. Alright, that's probably enough of that. So time dilation, as I've explained before, would just be a consequence of the fact that if you're moving something, it means you've added force, and that's going to disrupt all the other arrangements inside the material. So something that has velocity is going to be disrupted in its function. And in a sense, you can consider that the analogy of multitasking, I think, is a good enough one. If something has to do more than what it was doing before, it can't do what it was doing before as fast. So if you add more force and you've made a bigger circle, and there's one dot in the circle that is, the dot that tells how often a radioactive decay happens. Well, now you've just changed the timing cycle of when that dot makes a full circle. You can sort of see it that way. If you make the circle bigger and smaller and you keep the speed the same, you can sort of understand that the timing's going to change. And that's what happens to muons when they're hit by cosmic rays, and they don't decay as fast as they do when they're not hit by a cosmic ray. So when they're not traveling extra speed very fast because they got hit by a high energy, then they decay much quicker than if they're moving really fast. And that's because that timing cycle has been broken. So that's the nature of time dilation, and has nothing to do with time being a dimension and being warped and all that stuff. It just has to do with you can't do things as fast if you have to do more things. The things you were doing won't get done as fast if you have chores, you have 7 chores to do, and I give you 2 more chores to do, you can understand that if you have to do them in the same amount of time, something's got to break. Something like that. Alright, so what else? Yeah, so velocity is the interesting one, because it'd be a lot simpler if you could just say the matter bits were just one kind of bit, and it wasn't this proton and electron thing, and you just said, okay, you just have a solid bit that is able to reflect these little tons, and that would make it simple. But the truth is it's more complicated in terms of the things that can have velocity have to be, that can hold their velocity, maintain it, have to have a structure that allows them to store the force. If they don't have any structure for storing force, then they can't keep it. They can't preserve it, and they'll lose it. So when electrons move, they're moving in an environment that's constantly hitting them with, from all sides. And what's really happening is the perpendicular sides. I've explained this before, but I'll explain it again. So say this pen, again, was an electron, and it was an electron that now has 7 bits moving this way and 3 bits moving that way. So it's moving this way. But if it keeps getting hit from the sides with equal pressure, those impacts will be like before, they'll exchange. And so the 7-bit piece and the 3-bit piece, just by probability, the 7 is going to get hit more often. So more is going to get knocked off the 7 than it'll get knocked off the 3. And so it'll constantly be forced to balance. So electrons can't hold a velocity. They can be accelerated, and they can be continually pushed by force. You can just keep pushing them with something, like a charge, a pressure, which is the same thing as hitting them with something. And the pressure will keep pushing them. But if you stop pushing, they'll pretty quickly lose their velocity and go wherever the field, the charge, is the most favorable. So if you can build a little perfect sphere where you can create a perfect no charge in the middle, then maybe they'll just stay still. But in most places in the universe, if you place an electron in any point in empties, even in this room, if I place an electron, there's definitely charge variations in this field, and the electron will go where the flow goes, where the electron-proton balance will end up pushing it. The quanta being exchanged by electrons and protons in this field, there's an overall, in every location there's a charge, plus something. Yeah, I think it'd be stated it's just a plus force. There either is a I have to say it right. Because the electron and the proton are opposite forces, you can just make a linear scale, and you can just say it's a +7, and 0 can be the end. 0 charge, which probably can't exist, but regardless. And so what you're just doing is comparing the 7 to a location where it's a 3 or a 2 or a 10 or some other number, and it will go where the lowest number is, so to speak, where the least repulsion is. It'll just obey the same rules. It's a pressure universe. That's all. All right. I don't think I need to bother with like entanglement. I'm saying there's probably no entanglement. That's just rubbish. You start off with left and right gloves. You make 2 photons at the same time. One's polarized one way, one's polarized the opposite way because one came out this way and one came out that way. Whatever the cause is, but the 2 things were already established to be opposite each other when they left, or the same as each other when they left, and there's no spooky action at a distance. So I don't think entanglement is even a subject that has to be dealt with. because there's only a few experiments that even indicate anything close to it. It's kind of like the double slit experiment. It's one phenomenon in one circumstance, and to assume it means something about what photons are doing is just a wrong assumption, in my opinion. There's simpler explanations that don't involve photons having all kinds of power. And photons are, again, as stated, there's these simple little quanta. They just go in a direction. They always travel a certain amount of distance in a certain amount of time, and they just go in a direction, and that's all they do. They don't do anything else. They don't do multiple velocities and decide which way to go. They don't get pushed somewhere else. They either get absorbed and admitted in a new direction. They either reflect or they don't do anything. That's it, pretty much. They don't have another function. Alright, so yeah, so I won't go into this too deeply. So anyway, so the point is that, you know, for the people maligning the significance of what I'm talking about, and the fact that it does actually unify physics in the sense that all the forces are converted into just one force, and understanding these subtle differences. Photons are merely these little quanta bits at a frequency, that is, they're traveling the same path at a set rate. You know, and gravitons are just the mixture of red and black, random, no frequencies necessarily. They certainly probably can duplicate a photon now and then by accident, but it's that's all it is a random photon, just by pattern. And magnetism is creating a magnetic filter that ends up basically separating the two kinds of tons, two kinds of force. Yeah, so yeah, the thing I was thinking about, okay, so I'll throw this in just because, you know, every day I think about this stuff, and some days are more fruitful than others, but I always think of something, and I wish I took better notes, because I really need to do that every day. But I was thinking about this movement argument, you know, because we're all getting jostled, and we're moving in all kinds of different ways, but movement has a trick to it, in that it's this circular argument that by the physics rules, all of these movements count as having a portion in this direction. So when something's moving this way, it can be moving that way doing this. It can be going a lot of different ways, all of them with a portion going this way, and that will add up to a velocity. So the matter inside of you is doing that especially when you're being accelerated. The bits are being moved in all kinds of ways that have a portion in the way the force is being applied. So the force can come in all kinds of directions, and it will average out to a direction, but that average can contain lots of different kinds of movement. Well, anyway, so everything's moving a lot in terms of the little bits inside of you are not stable little bits in stable, perfectly stable positions. Your mass is vibrating. And I was thinking about radio waves versus, say, photons, because, well, the thought about this is the Ken Wheeler guy never makes a distinction. He talks about photons, but he doesn't recognize the fact that the same tons are doing radio and cosmic rays and all this other stuff. It's all the same, X-rays. It's all the same tons. They're just at a different frequency. I mean, I don't think anybody would argue that fact. They're not different tons. They're the same thing. They're just changed in frequency. And so I was thinking about the resolution you get with these different tons, right? The smaller, the tighter the frequency, the better you can use them to see something. So you can throw them, so to speak, and aim them at something, bounce them back, and you'll see more detail the higher frequency you can use. So the higher the frequency, the more detail you can get. And somehow you lose detail when you use things with a longer frequency, let's say. And I was thinking about what's a good reason for that. And the reason just might be is because the thing moved while you were, in the time it took the second, cannonball to get to it, in the time it took the wavelength to complete its interaction with the object moved. And that's why you get this blurriness. So the blurriness is being caused because there isn't a consistency between what by my theory, the first ton hit versus what the second ton hit. They're not hitting the same surface. And that's why they come back with a blurry or an averaged representation. So if you have a little tiny defect in this pen that's sticking out, you might be able to see it with blue light, but you won't see it with red light. So if I make it small enough, the idea would be is that it's going to move enough where the blue light, it can't move fast enough for the blue light not to hit both the tons, the whole wavelength to go into it without it, so it's going to reflect off exactly the same point. But the red light won't reflect off the same point, so you'll get back a reflection that is mixed and averaged. And so that's why radio waves don't work for seeing or illuminating. See, that was the word I used. Light's just illumination. Well, clearly some of these forces aren't very illuminating. And they're not going to give you much detail. They're not going to show you much of the world. Because the problem is their wavelength is so long that by the time see, again, my ton theory works really well at explaining it, but this idea of a 3-mile long wave doesn't. But the point is that the location is moving while your wavelength is interacting. So the beginning of the wavelength is hitting something, and the end of the wavelength is hitting something else. So anyway, I just thought that was, I think that's probably fruitful ground for contemplation. I think that it does explain, it first explains why long wavelength radiation isn't good for detail resolution, but it also goes to this argument about velocity and the speed of light, and why we can't shoot photons straight is because if our slits are if the surfaces are constantly moving, the photons are going through a different location. This is blocked, and then it's open, and it's blocked, and so that kind of thing is happening. And so the photons are getting interfered with by the actual thing you're passing the light besides, because it's moving. Okay, so maybe that's enough. So again, I'm just arguing that this is not just trivial, and in terms of the scope, I mean, how much of physics it covers, and the fact that it unifies all of it, and it does so recognizing conservation and not ever creating any free movements, no need for virtual photons, no magic fields, no bent anything, nothing invisible, so to speak, nothing unaccounted for as a mechanism beyond the simple rules that one color reflects and one color changes its direction. That's it. Beyond that 9-degree turn versus a pure reflection, that's the only there's no explanation for why exactly that happens. It's clearly being attributed to a mechanical function. I'm clearly saying it's mechanical, It's not a magic force. There's something about the structure of the electron and the structure of the proton that forces that to be the outcome. But I don't have a drawing of that yet. But it's not a bent space. It's not a bent, it's not an ether. It's not a field of who knows what. Yeah, and so I think it's the fact that it does unify all of these forces is very significant. It's, yes, circumstantial evidence of correctness, but it's pretty profoundly weighty evidence in the sense that it's very hard to construct any kind of theory that can do that with so few moving parts. So if you can show me some competing theory that has this few axioms and premises built into it, this few moving parts, that actually is consistent with, in generally speaking, the entire package of experimental observation. Highly significant. To be trivialized and maligned as nonsense or rubbish or useless imaginations and all this other rhetoric is totally inappropriate. It's just, you can't defend that if you have any intellectual integrity, because it's even if it's wrong, it's profoundly curious that such a simple model can be made that agrees with so much of the observed facts. Okay, that's probably the best way I can say it. Yep. So, kind of an overview video. There's a lot of stuff to get to, and a lot of stuff I didn't say here that I probably needed to say because somebody's going to ask some dumb question, but whatever. It is what it is as a video. So, till next time. See, I got my little note here. The three forces travel at the same speed and obey the same rules of straight line divergence. Yes. They're all inverse square. They all have the potential to create the inverse square law, and under different circumstances, different pressure effects that are all the byproduct of all of Maxwell's equations. They're perfectly consistent with all of that. And Einstein's, basically, his theory, his field equations are basically just a fourth Maxwell equation. But anyway, it's a lot more complicated, fortunately. Anyway, that's enough. Yeah, till next time, such, so forth and whatnot.